Hello students, welcome back to your class. Today we are going to see the third measure of dispersion, that is mean deviation. Already we have covered range and quartile deviation. So this is the third one, that is mean deviation, okay? And in that we are going to see individual series today. So what do you mean by mean deviation? It is also known as average deviation. Okay, mean you have already studied in the first measures of central tendency, arithmetic mean. Okay, they are all known as different averages. So mean deviation is also known as average deviation. So we are going to see how far the deviation is there from the mean, okay, or median or mode. So we are going to see under three different averages. It is whether it is mean, median or mode. We can calculate mean deviation from all these three, but in particular we are going to calculate mean from mean and median. Okay, so once if you have studied clearly what is mean and median, this particular problem is very simple. Okay, so in this case deviation is taken from any average, especially mean, median or mode. So while we are taking the deviations, we are ignoring the negative signs and we consider all of them as positive. So when we are taking the deviations, usually for example, if normally 15 minus 20 is equal to minus 5, we write it as minus 5. But here under mean deviation, we are going to consider all the values as positive. Okay, we are ignoring all the negative signs and we are considering all of them as positive. So now let us see the mean deviation formula. Here for the calculation of mean deviation under individual series, the formula is mean deviation is equal to summation d by n. So I have given you here twice, that is mean deviation is equal to summation d by n. So here I have also noted as x bar and m. Can you see that clearly? That is x bar means that is mean deviation is calculated from mean, and m here I have given as m. What is this m? That is we are going to calculate the mean deviation from median. Okay, we are going to see we are going to calculate mean deviation either from mean or median. So here the formula is the same, that is summation d bar. This also we are going to tell it as d bar. We are representing it within two lines, d bar. Okay, summation d bar by n. So here if you have a coefficient of mean deviation also, that is whenever we are calculating mean deviation, we also have to calculate coefficient of mean deviation. Okay, so the mean deviation for formula is mean deviation is equal to summation d bar divided by n, and coefficient of mean deviation is equal to mean deviation divided by x bar. Okay, when we are calculating mean deviation from mean, then in the denominator we'll be having x bar. We'll be having x bar. And if you're calculating mean deviation from median, then in the denominator we'll be having median. Okay, so what is the difference? So we can we can calculate mean deviation either from mean or from median. So you should be very careful when you're calculating the coefficient of mean deviation, in which you're calculating either from mean. If you're calculating mean deviation from mean, then the coefficient of mean deviation is equal to mean deviation divided by x bar. Okay, so if you're going to calculate mean deviation from median, then the coefficient of mean deviation is equal to mean deviation divided by median. Okay, so this is the difference. You should understand the formula clearly. If we can calculate either from mean or median. So when we are calculating from mean, then the coefficient of mean deviation is equal to mean deviation divided by mean, that is x bar. Okay, now let us see a problem. So calculate mean deviation from mean as well as from median and the coefficient of mean deviation from the following data. So this particular problem, it comes under that is individual series. Why do we say that it comes under individual series? Because we have only one variable, that is marks. Okay, so this comes under x. So x is equal to 20, 22, 25, 38, 40, 50, 65, 70, 75. So this is the question that I have given you. Let us see the calculation. So the question we have been asked that calculate mean deviation from mean and also from the median. Okay, so we are going to calculate both from mean as well as from the median separately. So here, see in the table, I have given marks. That is, we are taking the marks as x. Okay, this is x. And before calculating the deviation, we should see that from where we are going to calculate, that is either from mean or median. So first we are going to calculate the mean deviation from mean. So here you can see that the formula is, first we have to calculate x bar. So x bar means what? X bar is mean. So we are calculating mean deviation from mean. So x bar is equal to summation x by n. So I have already calculated summation x here. What is summation x? Summation x is 405. So how many values have been given under x? So here let us count here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 405 divided by n, that is x bar. I hope you remember that. That is summation x is equal to, that is x bar is equal to summation x by n. That is 405 divided by 9, that is equal to 45. Do you remember the formula for x bar? What is x bar formula? X bar is equal to summation x by n, that is equal to 405 divided by 9, that is equal to 45. Okay, I hope you all remember this formula, x bar. That is x bar is equal to 45. Now, we have to, after calculating x bar, we have to go with the table now. See, first what should we do? We should have to calculate summation x, then we move on with x bar, then we have to come to this deviations. So we have to calculate the deviations now. So this part. Okay, first we calculate only this one alone. Till x bar we calculated. Now we are moving on to the deviations. What is deviations? That is x minus x bar. Okay, that is the deviation from mean. அதாவது மீன்ல இருந்து நம்ம வந்து deviation எடுக்கிறோம். ஸோ அதனால் என்ன பண்ணுறோம்? x minus x bar. For example, first வந்து என்னது? 20 minus what is x bar value? X bar value is 45. See here we have got x bar is equal to 45. Okay, now in this table we are going to take this deviation, that is 20 minus 45, that is equal to 25. Okay, then the second one is 22. Can you see this? Is it visible? So here first one is 20 minus 45, that is equal to 25. Then second one is 22 minus 45 is equal to 23. Then 25 minus 45, that is equal to 20. 38 minus 45, that is 7. So we have to, like this, similarly we have to calculate the deviations from all these x values. So final answer is summation dx is equal to 160. So I've already told you that no negative signs. நெகட்டிவ் சைன்ஸை இக்னோர் பண்ணிடுங்க. என்ன வேல்யூ கிடைக்குதோ அதை மட்டும் எடுத்து எழுதுங்க. ஸோ ஃபார் எக்ஸாம்பிள் 20 minus 45 நம்ம யூஸ்வலாக நம்ம என்ன சொல்லுவோம்? -25 சொல்லுவோம். பட் ஆனால் நம்ம வந்து இங்கே வந்து என்ன பண்ணியிருக்கோம்? நம்ம வந்து we have taken 20 minus 45 அப்படிங்கிறது வந்து என்னென்னு எடுத்துருக்கோம்? 25 மட்டும் எடுத்திருக்கோம். அதே மாதிரி 22 minus 45 வந்து 23. ஸோ இங்கே வந்து we have ignored all the negative signs and we have taken only the values here. Okay, now after calculating the summation summation dx d bar, okay, summation d bar, that is 160. Now we are moving on to the mean deviation formula. First we calculated only x bar. Now we are moving on to the mean deviation formula. So what is mean deviation formula? Summation d bar divided by n. So what is summation d bar? That is 160. That only we have taken here. Okay, I hope you all understood this. That is summation d bar is equal to 160, and what is n? 9. So 160 divided by 9, that is equal to 17.78. Okay, this is the mean deviation value. Mean deviation is equal to how much? Mean deviation is equal to 17.78. Okay, now we have to calculate coefficient of mean deviation. What is the formula? Mean deviation divided by x bar. Why do we take here x bar? Because we have calculated the mean deviation from x bar. That is why we are taking x bar in the denominator. So the answer is 17.78 divided by 45, that is equal to 0.39. So this is a value for coefficient of mean deviation. I hope you all understood. So the next class we are going to see we are going to calculate mean deviation from median. Okay, thank you dear students.